This topic is about deriving the equation of a circle and being able to find the center and radius of a circle given the equation and vice versa. I will go through the key concepts and examples. Feel free to pause as and when you wish. Now, to derive the equation of a circle, let's say the circle has center AB and radius R. Now let's call this point, which is a general point on the circle, X, Y. Now if I were to make a right angle triangle with this, then it would satisfy Pythagoras. The distance between that point and that point is y minus b, and the distance between this point and that point is x minus a. So because it's a right angle triangle, it would satisfy Pythagoras theorem. So that means x minus a squared plus y minus b squared must be equal to r squared, where AB is equal to the center of circle and R is equal to the radius of the circle. So this is the equation of a circle. The two other formulae that you need for this topic is if you have 2 points, x1, y1, and x2, y2, to work out the distance, which is from there to there. Again, if I were to make a right angle triangle, then this would satisfy Pythagoras theorem, which would mean that this length, which is y2 minus y1, and this length, which is x2 minus x1, and d will all satisfy Pythagoras theorem. So that means d squared must be equal to x2 minus x1 squared plus y2 minus y1 squared, which means d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula, the distance between 2 points. And the last formula that you need is if you have, again, x1, y1 and x2, y2. If you want to find the midpoint, the middle of the point, so midpoint is equal to, you add the x coordinates together and divide by 2, and you add the y coordinates together and divide by 2. So the midpoint of 2 points. So these three are the equations that you need for this topic. Let us go through some examples now. The line AB is the diameter of a circle. So let's draw a rough sketch. So we've got A and B. Because it's the diameter of a circle, it must go through the center, where A is 4,7 and B is minus 8,3, respectively. Find the equation of the circle. Now, if I want to find the equation of the circle, first of all, I need to find the midpoint of A and B, because that would be the center. So midpoint of AB equals circle center, which I get if I add the x coordinates together and divide by 2, and add the y coordinates together and divide by 2. I get minus 4 divided by 2, which is minus 2, and 10 divided by 2, which is 5. That means that point there is negative 2, 5. Okay, so I know that my equation of a circle will be x plus 2 squared plus y minus 5 squared is equal to r squared, which I haven't worked out. Now if I want to work out r, I just need to work out the distance between either the circle centre and B or the circle centre and A. So depending on which one you want to look at. So either that one or that one. So I'm going to go from R and A. So R will be equal to square root of, so x2 minus x1 squared, so 4 minus 2 squared plus 7 minus 5 squared. So using this point and this point, which gives me 6 squared plus 2 squared, which is equal to square root of 40. That means, because I know what r is now, if r is square root of 40, it implies r squared is equal to 40. So my equation of my circle will be x plus 2 squared plus y minus 5 squared is equal to 40. Okay, the next example now. The line 4x minus 3y minus 40 equals 0 touches the circle x minus 2 plus y minus 6 squared is equal to 100. That means the center of this circle is 2, 6, and the radius is square root of 100, which is equal to 10. So if I were to do a rough sketch, my circle center will be at 2, 6. The radius is 10. Somewhere on this circle, I'm going to have a tangent which touches, because it touches the circle, it's a tangent. Okay, it touches it at point P, which is 10, 0. And the line is 4x minus 3y minus 40 is equal to 0. The equation of that line that touches the point at the point P. Now I need to show that the radius at P is perpendicular to the line L. Okay, the first thing I want to work out is the gradient of the line L. So I've got 4x minus 3y minus 40 equals 0. If I rearrange this, I take the 3y to the right hand side, negative 3y, I get 3y is equal to 4x minus 40. If I divide through by 3, I get y is equal to 4 over 3x minus 40 over 3, which implies that the gradient of the line L, which is this line L, is equal to 4 over 3. Next, I want to work out the gradient of the radius. So gradient of the radius. Okay, so if I want to work out the gradient of the radius, so gradient of the radius is change in y over change in x. So it's 0 minus 6 over 10 minus 2, which gives me negative 6 over 8, which is equal to negative 3/4. Now, gradient of the radius times by the gradient of the line is equal to 4 over 3 times by negative 3 over 4, which is equal to negative 1. Therefore, radius at P is perpendicular to line L. And we have just proven what we were asked to. Okay, next example. The point P 1 minus 2 lies on the circle center 4, 6. So if I have a circle with center 4, 6, and the point P, which is 1 minus 2, it lies on this. Find the equation of the circle. The first thing I know is the equation is of the form x minus 4 squared plus y minus 6 squared is equal to r squared. In order to find r, I can use the distance between 2 points formula. So r squared will be equal to 4 minus 1 squared plus 6 minus minus 2 squared, which gives me 3 squared plus 8 squared, which is equal to 64 plus 9, which is equal to 73, which implies r is equal to square root of 73. Okay, but now that we know what r squared is, we can just substitute into here. So I end up getting x minus 4 squared plus y minus 6 squared is equal to 73. Okay, part B, find the equation of the tangent to the circle at P. So tangent to the circle is this one. Okay, so we're trying to find the equation of that. So if, in order to know the gradient of the line, the tangent at the circle, I need to find out the gradient of the radius. Gradient of the radius is change in y over change in x, which is equal to minus 2 take away 6 over 1 take away 4, which gives me negative 8 over negative 3, which is 8 over 3. This implies the gradient of the tangent, is equal to negative 1 over 8 over 3, which is equal to negative 3 over 8. Now, because this point goes through 1, this tangent goes through 1 minus 2, using my equation of a line formula, I end up getting y minus minus 2 is equal to minus 3 over 8 times x minus 1. So y plus 2 is equal to minus 3 over 8 times x minus 1. I can leave in this form, but I prefer to have it all in terms of integers. So if I multiply everything by 8, I get 8y plus 16 is equal to negative 3 times x take away 1, which gives me 8y plus 16 is equal to negative 3x plus 3. And my final answer will therefore, if I take everything to the left-hand side, I end up getting 3x plus 8y plus 13 equals 0. And that would be my final solution for that one. Okay, so the tangent to the circle x plus 4 squared plus y minus 1 squared is equal to 242 at 7 minus 10 meets the y-axis at S and the x-axis at T. So from there I know minus 4, 1 is the center of the circle. The radius is equal to square root of 242. Okay, if I were to sketch this out roughly. Okay, this is my circle center. This is my radius of, it's a rough sketch, don't worry about accuracy, square root of 242. And meet, so at 7 minus 10, so 7 minus 10, let's say somewhere here, 7 minus 10. So there's a tangent at that point. So it meets the y-axis at S and meets the x-axis at T. We're trying to find the coordinates of S and T. So the first thing I would work out is the gradient of the radius. So the gradient of the radius from here to here, so from there to there. Okay, so I get change in y over change in x, which is negative 10 take away 1 over 7 take away negative 4, which is negative 11 over 11, which is negative 1. So the gradient of the radius is -1, which means the gradient of the tangent, because it's perpendicular to the radius, is a negative reciprocal of it, which means it's equal to 1. Now we know that the gradient of the tangent is 1, and it goes through the point, this point 7 minus 10. Then using y minus y1 is equal to m times x minus x1, which is the equation of the line formula, we end up getting y minus minus 10 is equal to 1 times x minus 7 is the equation of the line, which gives you y plus 10 is equal to x take away 7, y is equal to x take away 17. So this is the equation of the line, y is equal to x, or the tangent, x take away 17. Now, to find the s is the y, obviously the y-intercept, which implies x is equal to 0. So y must be equal to negative 17. So s will be equal to 0, negative 17. T is the x-intercept, which implies y equal to 0, which implies 0 is equal to x take away 17. So x is equal to 17, which means t is equal to 17, 0. Okay, part B now. It says find the area of triangle OST, where O is the origin. So if I were to use a different color, this is O, and we're trying to work out this, which is a right angle triangle. So it's, because it's a right angle triangle, it's half times base times height, which is half times 17 times 17, which is equal to 289 over 2 units squared, because it's area. Okay, moving on to the last example. We're trying to write down possible equations for each circle. So if we have this point, circle center is AB, and this is the radius, then we can clearly see that the radius must be less than A, and the radius must be less than B, because it's not crossing the x-axis or the y-axis, or it's not touching it either. So that means it can be an equation of the form x minus 4 squared plus y minus 4 squared is equal to 2 squared, because that would mean the center is 4, 4, and the radius is 2, and obviously 2 is smaller than both 4 and 4, so that would work. Okay, that's one possible solution. There's multiple solutions. Okay, in this example, the only difference being for this one is that the circle is in the second quadrant, which would mean A must be negative, B is still positive. So that means if we change the first bracket to x plus 4 squared plus y minus 4 squared is equal to 2 squared, then that would work, because that would be negative 4, 4 would be the circle center for that circle, and the radius is smaller than 4. That's why it's not touching or crossing the x or y intercept. Now, in the third example, the radius must be, because this point is AB and it touches the x-axis and the y-axis, r must be equal to A and r must be equal to B, which means A must be equal to B. So anything of the form x plus 2 squared, oops, not plus 2, because it has to be because the circle center is in the first quadrant, it must be x minus 2 squared plus y minus 2 squared is equal to 2 squared. So all these numbers should be the same. Okay, in this example, if this is the circle center and this is the radius, then you can clearly see r must be equal to a. But r must also be greater than b, because you can see it has crossed the x-axis twice. Okay, now because the circle center is in the first quadrant, it must be of the form x minus 3 squared plus y minus 1 squared is equal to 3 squared. Now you can see both a and the radius are the same, so that means it would touch the y-axis. But also the b is equal to 1, which means it will cross the x-axis twice. Okay, so that is an example that would work for that one. Okay, remember these have multiple solutions. As long as they satisfy, obviously, the criteria that are written, it should work.